yes, that is probably the most important of all the things I mentioned, is the time. It is a big time commitment, seriously, no joke. It is a time commitment, and you'll have to devote quite a few hours to it, so per week. So please, if you're kind of stretched thin right now, we'd love to have you, but unfortunately we need someone with a lot of time, so just something to consider. All right, and we have Ian Furr up next to talk about next talk.
Thank you, Russ. All right, hello everybody. Hello. So I'm here to talk about NSIC. For those of you that don't know, NSIC is the competition that Nextop runs during the spring semester, where we focus on building out an infrastructure and doing lots of sysadmin and networking things. This year, the competition is going to be on March 30th and 31st. It is a 2-day competition. We do competition one day with a break for lunch and then an after competition event, and then competition starting again the next morning through to the afternoon where we have the final scoring and stuff like that. This year, we have just opened the registration and we have spots for 10 teams, and we have both team and individual registration. Teams are of 5, but if you have a team of 4, you can still fill out the form and we will fill in people into those teams from the individual registrations. So if you're interested in the competition, please go ahead and if you have a team together already, fill out the team registration form. And if you have just you and you want to compete, please fill out the individual form down the bottom. Thank you guys so much.
Thank you, Ian. Yeah, I competed in Nextop my sophomore year, and it was a great learning experience, and I learned so much from it in terms of like networking and setting up infrastructure. So I'm going to vouch for it and say it's a great competition, and even if you're a beginner in network like I was and still am, it's a great experience. Joe.
What does NSIC stand for?
NSIC, what does NSIC stand for? Ian, what does NSIC stand for?
Networking Systems Infrastructure.
Thank you, yeah. Let's get a round of applause for that. All right. Thank you, Ian. I appreciate the time. So without further ado, this week, as you guys know, is advanced networking, which is kind of ironic since we're just talking about Nextop. So if after this presentation, you should be all geared up for Nextop.
I'm going to stay up before you continue.
Oh, really? Okay.
Yeah, I had an announcement. Tonight, LAN party, 8 o'clock Sec Lab. Come on out. We have a few tickets left for the hackathon next week. So if you want to do that, sign up. The link is in Workplace under announcements. Yep.
All right. Thank you, Jack. All right, yeah, Halo's great. I might be there to pwn you guys, so if you're looking to get slapped, then show up. But just kidding, I'm not really good. So anyway, yeah, we have advanced networking this week, and I always like to get like the best people to show up. So I personally myself called up like the Cisco CEO and was like, hey, I need the best guys in the world for networking. Like, who you got? And so they gave me 4 names, and they're here today to present advanced networking to you guys. So I hope you're ready. So I'd like to please welcome up Owen Siebert, Nick Racca, Ian Furr, and last but certainly not least, Joe Graham. Jack, how should we do the mic thing?
We'll just hand it off to each other.
Just hand it off. All right. Yep. You guys can figure it out.
Hey guys. 4 people presenting all at once. That's so crazy. We're going to talk about advanced networking. Jack, let me know if you can't hear anything.
I'll do one of these.
All right. You may want to shout too. So real quick, I'll start because my name's first. I'm Joe Graham. I presented last week too. So maybe I'll just keep presenting every week. It'll be really fun. Last year, I was the president of Nextop. Nextop's a really good club if you want to learn more about networking and systems administration. I'm not this year because I really like having free time in my last year at RIT. I'm still trying to figure it out because I still said I would do all the other competitions. So yeah, I've been doing networking for a while. I helped with networking for the CCDC team the last couple of years. It's something I really like, whether it be talking about the security of like actual firmware on a device or doing the firewall rule configuration itself. So yeah.
Hey guys, what's up? I'm Ian. I was up here literally a minute ago. So I am the vice president of Nextop this year and excited to see all you guys come to NSIC.
All right, I'm Owen. I'm the treasurer of Nextop. Yeah, come to NSIC. It's pretty cool. We're going to have some dope prizes probably. So yeah.
My name's Nick. I'm not on e-board for Nextop, but I am a member. So yeah, that's pretty much it.
Well said. All right.
Back to you, Joe.
Thanks. Thanks. So we actually have speaker notes for these slides, so we're going to take a quick pause so that we can look at our speaker notes. Most of the content is actually in the slides because I know I've gone through. Back in the day, when you're trying to do a challenge, you're working on a demo, and you're like, damn, it would be really nice if the content was actually in the presentation. But unfortunately, we do have a couple of things that are going to help us guide us on this journey through networking. I'm running out of things to say.
Do you want to clip the mic to the mic? That way we don't have to hold it.
Is that a good idea? You want to try that?
Go for it.
All right. Oh. I would have to be funny to do that. Sorry, Boyle.
Which one are you recording, Jack? Jack.
Jack.
What?
Which one are you recording?
Yes, all of them.
All screens?
Yeah, we got it. You're good.
Okay.
Yeah, you're fine.
All right. Let's get back on track. Jack, let me know if this sounds weird. Oh, awesome. We should just do that every year. No, I'm just kidding. It's easier when it's right here. All right. This is not my slide.
This one is my slide. All right. Okay. So first we're going to talk about routers. There are our first line of events when it comes to a network. All traffic entering your network will come through the router. As the name implies, it routes packets. So it takes packets based on their IP address and sends them where they need to go. Okay, we're going to fix this.
That's not going
Is that better?
Just hold it. We tried. It did not.
All right. Okay. Where did I stop? Okay, yes, routes packets based on IP address coming into your network. It is the gateway. Yeah, we went over that. Considerations, patches and updates. If your router is out of date, it very well might have vulnerabilities. Keep your stuff up to date, kids. Protocols, certain protocols are allowed that don't need to be allowed, that can leave holes in your network and allow people in that you don't want in. So make sure that you're only allowing through what you want through. Administrative access, don't just leave admin access on your WAN port to all of the internet to come to. That's dumb. Services, you don't need a web server on your router. If you can get to your administrative page from your WAN port, again, not a good idea. Audit and logging, hey, keep logs. If you see anything bad on your router coming in, you should maybe see what that is about. Okay, firewalls. So ideally, once you get through your router, it should hit a firewall. And that firewall should say, hey, is this something I want here? It got through the router, but do I care about it? So it is our second line of defense. Yes, so it is between your network and the router, which is the gateway to the outside world. Again, keep your stuff up to date, kids. We don't need old things here. Rule design. So, are we talking about? We talk about ACL this later, correct?
Yeah.
Okay. So, make sure your ACL's in the right order. We'll touch on that later. Network design. Again, make sure everything's going through the firewall, so no bad things happen. Again, logs are pretty useful. Read your logs. You can see bad things. And services, not really. Okay, so now we're moving down to layer 2. Switches are MAC address based. So they're our third line of defense before the packets hit our computers. So it strips the packet out of the IP frame, IP header, and then forwards it based on MAC address is in your network. It segments your networks. It drops. No, it doesn't drop. I'm sorry. What am I don't know. Again, patch your stuff. VLANs, you can separate your network through VLANs, so not everything on your network needs to be in the same area, not everything needs to talk to each other if they don't need to. Insecure defaults, ARP poisoning is a thing, so you will look up MAC addresses in your ARP table, and if there's stuff there that if an attacker can poison that ARP table and send packets to the wrong computers, it'll compromise you. And yeah.
So like the meat and potatoes is like, how do you go from being super elite firewall that just gets obliterated by a hacker with one quick switch to actually being able to fight back against attacks and people trying to penetrate your network? There are a couple of features of a secure network. Unused protocols are going to be blocked, and ports as well. Ingress and egress filters are enabled. Ingress basically means something that's coming into the network. Egress means something that's going out of it. Obviously, if there is a protocol or port that's allowed out that like doesn't correspond to a service that needs to be able to get out or get in, shouldn't have that in there. Otherwise, that's like ports and protocols that malicious attackers could use to like beacon traffic out or like to exfiltrate data or send beacons out so that they can do like command and control, both of which are not things that you want and would probably be a little important for those of you who are going to be competing in a competition soon. ICMP traffic is either prevented or limited to necessary types. The Internet Control Message Protocol has like 1 million different requests, even though it's basically only known for being the protocol that does ping. So in the year of our Lord 2019, you don't really need to be using, you don't need to be allowing timestamp request ICMP packets to go through your firewall, for instance. ICMP can also be used as a, what am I thinking? It can be used to like send information out. Normally the data portion just has like a bunch of garbage in there, but you could use that to like send data over that. So covert channel is the word I was looking for. Thank you, Ian. You could use it as a covert channel. That can be pretty easily detected if you're doing any sort of like layer 7 firewall stuff. Things that are doing deep packet inspection that make sure that it actually is a normal echo request or echo reply instead of a bunch of like commands or command results going over it. Strong passwords everywhere. This is extremely important for network devices especially because basically if you set, and this happened a couple of years ago at IRSEC, if you set like a default password or if you change the password before one of us red teamers can get in and deploy our malware on your stuff, then we literally just cannot get in. So changing a default password, very obvious, like just do it. I got into like every single router last year at, or the red teamer who was doing networking last year got into every single router at IRSEC because the password wasn't changed immediately. Have like a dedicated person doing that. Unused services are disabled, like I just said. This also relates to like administrative interfaces on the router. There is a web interface that you can configure your Cisco routers on. You have no reason to leave that enabled if you are only using it, if you are only interacting with a router using the serial connection. Same thing with like SSH or Telnet, especially Telnet because that just sends things unencrypted. Traffic is being logged and devices are synchronized to the same time. The time difference helps for logging because if you're looking through logs and you see that it's all on like UTC or it's on a weird time zone or there's different times, it's going to make it more difficult for you to be able to like deconflict any malicious things that you see going on, which is important for doing instant response. Finally, I have these two bolded because I'm going to, well, not finally. Actually, yes, finally, because it's like the last real point I'm making. ACLs are super important. These are firewall rules that you can put into a router. I'll be talking about that in a little bit. And either disabling simple network management protocol or using version 3. Again, please change your passwords and encrypt your passwords on your config. By default, Cisco devices do not encrypt passwords or use hashed passwords. Even if you can use the configuration directive service password encryption, which is a command that will like try to encrypt everything within your config, by default that will use what's called a type 7, I almost said mode 7 again, type 7 password that is very easily reversed. It's a Vignere cipher. So extremely easy to be able to reverse it and get the password itself. Encrypt your passwords and do it in a strong way. Or use hashes, rather, because I know Nick O'Brien is cringing at my use of the word encryption, because it's not. Back to Owen. Yeah.
Let's get to the practical stuff. All right. So you sit down at a router. What do? You spam. You spam enter until you get this first prompt router with a little side caret dude, right? So that's your lowest level of mode, and you can't really do anything there. So we're going to type in enable, and that's going to escalate our privileges. So config T, that gets us to configure all of the important stuff on the router, basically. You can enable certain routing protocols, set rules, and stuff like that. So another basic command is show run. So that'll basically list out everything that the router is doing in a pretty readable fashion, right? So if you know what you're looking for, you can see what interface is designed to do, what protocols are running where, and how everything is set up. Show privilege, show your privilege level, I believe that is, and then enable password / enable secret password. Put passwords on your stuff. That's all I really need to say here. So the question mark key is honestly my favorite thing in the Cisco iOS, because whenever I don't know what I'm doing, I press question mark, and it shows every possible command you can do at that point in time. And you can kind of follow that through your path to get to your destination by spamming question mark. It's wonderful. All right, so like I said, there are different levels of privilege in the Cisco iOS, and it is a tree structure.
Yeah, sorry.
What?
Continue.
No? Again, so at your little caret level, that's your user level. Don't have much. You can do a couple show commands, but that doesn't give you much information. If there is no password, you can type in enable and get that little pound sign, and that's basically root. So you can see all of the configuration at that point and begin configuring stuff. And then the config mode is where you really get into the powerful area. You can define the rules for the router, how you want them to be. There's a nice little diagram right from the Cisco documentation on how the levels are broken up.
All right, these are some really quick commands that will help with the demo later on. Being able to SSH in the router should just work. You will see when you log in over the serial line, which I'll explain in the last slide. The first interface, which is the only interface that even shows up, is configured to use DHCP. So if you're on the wireless network here at RIT, set your VMware config so that it uses either the private or local network. I don't remember what it's called, but basically it should be only routable within your computer. VMware will deal with giving out a DHCP address and being able to communicate with it. If you're at home, just leave it bridged. It'll get an IP from your home network, and then you can SSH in there. I forgot to add this. The version of iOS uses a very old key exchange algorithm in order to do the SSH. So if you run the command, if it's not in Windows, you will get like a small error, but you should be able to like copy and paste that into the Google, and it'll tell you how to fix that. Configuring SCP, which might be important for one part of the challenge, is using that command. Basically, all you have to do, you just have to configure that, and then use SCP like you would with any other Linux or Unix host. All right, Nick.
Thank you. All right, so we've talked about ACLs a little bit, but now we're going to get more in depth with it. Basically, this tells you what you accept and what you deny based on like what goes through the firewall. So you can filter by protocol, IP address, source IP address, destination IP address, port number. It's very, very helpful and probably the first thing that you're going to do to try and secure your network. It also goes both ways. So you can configure a access control list for incoming traffic as well as outbound traffic. This is what I've already said a little bit, but you might want to, what? I don't think it jumped you. Oh, it did. Okay. Good catch, Ian. So this is very important. ACLs, it'll go through sequentially from top to bottom. So if it matches one of the rules, it'll, as soon as it matches, it'll accept it or deny it based on what the rule says. And at the very end, it has a deny all. So if it goes through the whole list and it doesn't match any of the rules, it'll automatically deny. You have to be careful with this because sometimes you may want it to do something, but it hits a rule and above it, and it doesn't get to the rule that you think you put, if that makes sense. Yeah, so make sure that when you are configuring your ACLs, that you do it in order. Yes. The space bar. So you may be wondering why inbound and outbound. So if, say, an attacker does get into your network and gets hold of one of your boxes, it can beacon out, and you obviously don't want that. So if it doesn't catch it on the inbound, it may catch it on the outbound. So it's very helpful having both sets. So standard ACL. This is what a ACL command pretty much looks like. You can have different ACLs, numbered them from 1 to 99, and you can apply them to different interfaces. So one ACL might not be applicable to one interface, so that's why you have multiple ACLs. And then you can apply them to various interfaces. Oh, and make sure you have your wildcard mask, so you know what IP addresses this will apply to. It's very important. This is more on ACLs. You can do more with it. You can have it log some of the rules. So at the very end, you can see there it has the operator, the port, and the log. The operator is the name or IP address of the log server, and you can just send it that way.
So a second ago, Nick mentioned wildcards, and these are a really powerful way to apply your rules to different sorts of traffic. So up from the top and just kind of going down, up top we have the host wildcard mask, and this means that you're applying it to all traffic that comes in, and anything that matches the host's IP address will be able to pass through. And yeah, so going down, we increase the amount of traffic that's going to be able to flow through. So the next one we have is going to match the last 24 bits, or the first 24 bits must match, and the last 24 is going to be able to change so that it's only going to match certain traffic in that network. Going down again, we're just going to match the first 8 bits, and down to the one below that, we have any traffic that's coming through. So if you're going to do an implicit allow all or deny all traffic, this is one of the ones that you're going to want to use because it's just going to take anything that comes through. And then the bottom two are just two different ways to, two additional ways to define specific amounts of bits that you're going to use for your host and the rest of the traffic that's going to be allowed through. So when you're designing ACLs, you've got to figure out how, specifically for competitions, you've got to figure out what's scored and how this traffic is actually going to be able to make it through your network to the scoring engine. So if you have things that are on specific subnets, you need to make sure that those are allowed out to the engine. Otherwise, you're not going to be able to score specific services until you figure out, oh, hey, we have an ACL that's just blocking all of this traffic. It helps to write down what's listening and where. So take the IP addresses and the ports that they need and make sure that those are all allowed through. And design rules that have both of those things in mind. Otherwise, like I mentioned, you'll be blocking off all the traffic that you need.
All right, this is like my favorite thing to explain. I realized as I was going through these slides from last year, I didn't actually have, I've done this explanation for like plenty of people before, but we didn't have slides dedicated to it. Wow, those numbers are impossible to read. Cool, that's good. So basically, here we have like a regular network. You have a laptop on the left, and I have enough of the IPs over here, so we'll be able to do fine. We have a laptop on the left. That's a client. In a competition environment, you would expect that to basically be the scoring engine that wants to connect to the web server on the right, which has an IP address of 10.10.20.1. Like most servers, it also has SSH listening, but obviously we don't want anybody to be able to access an SSH server. So one of the most important things to understand when you're writing these rules is that obviously like the primary objective is to secure your service so that just anybody, or secure services that aren't scored so that not anybody can just connect to them and wreak havoc. But you have to keep in mind that you have to keep up any other services that you need to maintain, like this web server. Otherwise, in a competition environment, you would lose points, or in the real world, you would have downtime, and that would be just as bad, if not worse. So I'm going to walk through what a request looks like at like the IP level and point out a really important component that you can predict no matter what kind of, no matter where the request is coming from so that you can only allow legitimate requests. So this first slide shows that this packet that's basically going to be created on the 10.10.1 client is for a web request to the web server. The source IP, obviously 10.10.1, the source port is 54321. This is just used for demonstration purposes in like the real world, or even when you're just going to the internet, like some of you are doing right now. Your operating system, when it binds a socket, which is how your web browser communicates over a network, it will assign a semi-random source port in the ephemeral port range, which is basically anything greater than, I don't have it memorized, but it's like a very big number. This is how you can differentiate between ports that are used by legitimate services and just random ports that need to be assigned by the operating system so the operating system can keep track of what network traffic is going where. The destination IP, we can guess, and the port is 80 because this is HTTP. As it moves along on its journey towards the web server, the router, which is the default, oh, actually I forgot this little part. This is kind of important just from like a networking perspective. The laptop notices that the web server is not in the local area network. It does like some math on the IP address and its own IP address and subnet and realizes that the network bits don't match and says, okay, this is outside of the local area network. I'm going to forward this to my default gateway, which hopefully should be able to forward it on. If not, then, well, we're not getting the web going. The router performs an Ingress ACL lookup first because obviously it doesn't want to go through all of this process and then be like, oh, this web request like can't even go in because we're not letting traffic from this IP address for some reason. If that passes, it does a network address translation. You guys hopefully are familiar with that, but if not, basically that's how we have a bunch of private IP addresses in a subnet that all gets translated into one public IP address. This was done so that we didn't run out of IPv4 addresses really quickly. It gets translated to the global IP. This is a really important part of writing the firewall rules because you could think like, oh, if we can predict what the source IP address of like every request is going to be, we can block on that. That's kind of ridiculous because we don't know all of the clients we're always going to have. Even if we did, we wouldn't be able to tell if they had NAT in front of it. 10.0.0.1 is the IP address of the router. I should have specified. That was a little clearer when I was looking at these slides on my laptop. Anyway, there's a NAT translation. It does a route lookup based on the destination IP, and then an egress ACL lookup. This is why we want to make sure that like any traffic that's coming in has ACLs that are set as far away from the destination as possible. Otherwise, it's going to go through all of this processing for no reason and then be like, oh, okay, I can't even send this out anyway, which is a huge waste of resources for a router. Routers do a lot of stuff, don't want to waste a lot of resources. Assuming there aren't any deny rules anywhere, the only thing that changes is the source IP of the request. Then it hops over, goes through the interwebs, gets over to the network of the web server, does the same order of operations, and then the server receives the request, sends it to the HTTP server, parses it, starts forming a response. Now this is a really important component, and it might be a little hard to read, but the thing that changed is the source and destination IPs flipped. So our source IP and port are 10.10.21, source port's 80, and the rest are the global IP address for the client. Oh, what's going on there? Oh, now I can read it. Yay. That is a little better. Now we can see the IPs of all of the requests. Thank you. Anyway, the destination IP is the client that requested it, and the port is still the same as well. And then it follows its way all the way back. So the things that we need to consider are that incoming requests from legitimate clients can get to the server. The thing that we will be able to identify here, obviously, is the destination IP and the destination port of the server. This is like a pretty easy thing for all of us to understand. But something that is so easy to forget, I've forgotten it plenty of times when running ACLs, and usually people have trouble with this because you're thinking, oh, I just want stuff to be able to get out. Core concept of like server-client communications, you need to be able to have responses being able to go back out from the client requests. In this case, the source IP and the source port are going to be the server. Like I said, we can't predict what the client is going to be, but we can predict what the server is going to be. So we use that information to be able to write ACL rules that allow legitimate traffic for scored services. Finally, the other thing you have to consider is that outgoing HTTP, DNS, ICMP, and maybe SSH being allowed out from the network. Obviously, you know, you're trying to solve a problem on a computer, especially in like a competition, when something has broken, you're getting a weird error from an application, you're going to get even more stressed out if you can't get out to the web or if DNS won't resolve. This is, again, something very easy to forget, but causes a huge headache. Keep these things in mind if you're like the routing person, because there's usually one person for each team, for whatever competitions you're doing, or if you want to get into networking in the future. Very easy to forget those last two things, but they're crucial for writing good ACLs. All right, back to Ian. Could we be able to not be so light now? Thank you.
Sorry for stealing your slide. No worries, bud. I thought mine were all on a block. That's okay. I'll wait for that to get back to the right color. There we go.
Thanks, Jack.
So Joe just mentioned a lot about creating ACLs and how they're used in like a competition environment and real world environments. So now I'm going to talk a little bit about the specifics of actually making them. So to create an access list on a Cisco device, actually first just to view them, you're going to do show access list, and that's going to show you all of the access lists that you have configured on that device. And you can do both the normal one, show access list, and show IP access lists, and that's going to display all of the ones specific to IP. So to actually add an ACL to an interface, you're going to first go to that elevated prompt that Owen was talking about. You're going to go into configuration mode, and then you're going to start creating the ACLs. So the first one we have right on that router B config line is going to be access list 1, which is just going to edit your first access list, deny, and then you have an IP address and then a mask. So the IP address tells you the beginning part, what you're going to actually combine with the mask to deny the traffic from. So we have a mask, which is just going to look at the last, or the first 3 of the 4 octets, and then the last octet is just going to be ignored. And then after that, we're saying access list 1, permit any, so we're permitting all traffic that doesn't match that first rule. And then we're going to apply that to the interface, F00, and add that to an access group. To view ACLs on an interface, which if you have several interfaces and you've got a bunch of access rules applied to different places on your router, this is really helpful because you're going to figure out, okay, this is the internal interface, and these are the rules we have applied here. This is the external, and these are the rules that we have applied here. What you're going to do is you're going to do show IP interface, and then look down right where that second arrow is, and you can see the outbound access list. And then down at the bottom, you've got more, and that shows that you have more stuff down below what you're seeing, similar to something like less, where you've got a whole bunch of text and you just need to view more down below. So if you've applied a bad ACL to an interface and you've just suddenly blocked off all the traffic to the scoring engine accidentally, you're going to want to remove that, otherwise you're never going to have scored services again. So what you're going to have to do is you're going to have to go in, go back into the configuration mode, go into the interface with the 00 or F0/0, and then do no IP access group 1 out. And what that's doing is basically when you put no in front of any or most commands on a iOS device, you're just deleting them or removing them. And that works almost anywhere. So unfortunately, ACLs aren't everything you need to succeed networking-wise in a competition environment. There's a lot that could be missed, but if you have good ACLs, you're going to get a lot of the stuff. You do have to allow some traffic, like we mentioned a lot, is the scoring stuff. You also need to be able to get out to the internet when you're trying to figure out why this thing is broken. You're going to want to be able to Google it. So to fix that, we have a lot of other things that can fill in those gaps. And one of the things is centralized logging. And this allows you to look at basically incidents that have happened on your network, and it gives you a view into them. So a SIEM, or a Security Information and Event Manager, allows you to actually, if properly set up, because I've done it in a competition where we've had one and it was virtually useless because we didn't have anything configured right, so we were just looking at a bunch of garbage. If you configure it right, it allows you to look at a lot of the traffic on your network, group it and organize it so that you can see specific things and how they can pose a threat to the environment. An example of SIEMs could be things like QRadar or Graylog, or like I'm about to talk about, Splunk. So, Snort, yep, that's what I meant. Snort is an open source intrusion prevention system capable of real-time traffic analysis and logging. So what it is, it's a rule-based intrusion prevention system which applies lots of different rules, and you can get some from the internet or create your own or subscribe to the rules that they have. And basically it filters through the traffic and looks at things that match the rules and things that don't. And depending on how you have the rules set up, it will alert, log, a whole bunch of things. And it's really powerful because you can create an alert for any traffic, say, to a specific device that you really want to monitor. And if you have traffic that's exceeding a threshold or from an unknown host, stuff like that, you can have an alert for it. And then you go, oh, we're not supposed to have traffic from this network to, say, the web server in our environment. Something must be going on. Back to Joe.
Talked about SNMP last week, how you can exploit it on certain ASAs. I'm going to talk about it again this week in a little more detail. Simple Network Management Protocol was designed as a way to gather information from very different systems in a consistent manner. Usually you're going to see this on network devices, but especially those of you who have done the OSCP, sometimes there are actually ways that you can install it on like Windows, Linux, and Macs. Super great. Most environments won't use it on like all of these different operating systems, but they do support it. There are two different concepts. There's the SNMP manager, which is basically like a central system that you use to collect all this information, and you have agents. So back in the day, we had version 1, which uses a read-only community string to authenticate. There's also read-write, which allows you to like change things on SNMP. You'll notice that I said community string. This is basically just a password that you just send it. And most environments would use the default like that's packaged, which would be public for read-only and private for read-write. This allows or denies access to a router's or other device's statistics, and community string is set in clear text. So anybody that's monitoring network traffic that has like network tap plugged in, or they've configured a span port, which just sends all of the traffic received on a certain port or a certain VLAN off to another port, they can see your community string in clear text, and then they would be able to go in and request all sorts of information from your devices. Version 2 implemented some efficient ways of getting a lot more data. In version 1, basically what you would do is you would just spam requests of like a whole bunch of different OIDs, which is the way that they represented a single piece of information within the operating system. It used a weird party-based security system. I don't even really remember how this works since I wrote this slide like 2 years ago, but nobody used it. That's why nobody talks about it. Then finally, version 3 added support for doing like proper authentication using a username and a password and access control so that only certain parts of like the information base could be sent out. Finally, it protected against messages getting modified in transit and used encryption of packets so that you can't man-in-the-middle stuff. It relies on the management information base. That was the information base I was just talking about, which just is a database of all of like the information within an operating system that could potentially be represented that the manager and agents follow. This is general here because different operating systems implement different MIBs. There's a MIB for Cisco iOS. There's a MIB for Windows, the various different versions of Windows, MIB for different types of Linux. There's even MIBs out there for like different Unix distributions. Not really great to call it that, but I guess versions. Anyway, you can secure this with ACLs as well so that only certain clients could be able to access the MIB. This is the way that you would do it. In this one, you do not allow access from 10.157.22.98, as well as from the subnets 10.157.23 or 24, but you allow anyone else to get in. This is kind of a weirdly written ACL, but yeah, so this would be a way that you would prevent access. Oh, I see what's going on here. I apologize. So there's two different ACLs set. One is 25, which only allows access from anyone that isn't in those subnets to the public read-only community string. So even if you know the community string and you send a request to the router, it will deny it if it's from one of those subnets. Same thing with 30. Yeah. And then you write it. So. Tool command language is a really fun thing that I love to talk about every year, and I'm going to go into a little more detail than I did last year. This is a general purpose, multi-paradigm system programming language. This is basically a programming language that existed before Python and tried to do some things like it, but not very well. It's a scripting language that aims at providing the ability for applications to communicate with each other. Yeah. What it means for Cisco devices is that you're basically allowed to write what are effectively your own programs that you can run on the router with a couple of small modifications. You can use it with Cisco devices via the TCL sh command, which I'll get into in the next slide. There's also a series of Unix-like SNMP commands that allow you to do like SNMP requests through Tickle. The Tickle shell is enabled manually or by using a Tickle script, and new commands can be entered to allow you to perform specified get and set actions on objects. Most people don't use Tickle for SNMP, which I'll get into in a minute, but basically you can set these commands to tell it where to look for specific URLs, sort of, locations on the router to look for scripts to run, and then use Tickle shell to like get into that shell. So how can I use this for malicious purposes? Basically by combining it with what's called the embedded event manager. This is something, another feature within Cisco, or within Cisco iOS, that was meant to like register actions to be taken by a script when an event happens. So let's say you have an interface that goes down and you want to have it automatically perform some troubleshooting in order to try to bring the interface back up. And if that doesn't work, send an email out to alert like your network operations team that the interface went down. You could do that using EEM. Nowadays, especially with like more advanced versions of iOS, people don't have to use Tickle to do this. You can use Ansible. There are different logging things that you can do so that it would get logged to a network device so you don't have to do this. But for backwards compatibility, they left all this stuff in. Tickle also allows you, I don't have it on the slide, but there are a couple of different features within Tickle that are like super spooky, especially the fact that you can create sockets to communicate over the network. Obviously, you don't really want to do that, but you can send a bunch of information back and forth on a network. You can also set it up so that it triggers whenever a command is run. This can also be used to change what is output on the CLI. which I have no idea why they did that. You could just tell it to print out a different set of information when a command is run, and it would be difficult for you to figure out why that happened. You can also set it up so that it just runs at random intervals. So let's say every 10 minutes I want it to pull back to a server, get a command, and then run it for it, and then send the response back. You can do that with Tickle. I'm really looking forward to when Cisco disables this feature within iOS, but for now, it's really fun to abuse. So that's all that we have. Do you guys have any questions? Doesn't look like it. All right. Will be available during the demo time anyway. This is an extremely long paragraph of text, so that I don't get 40 messages because I'm telling you to use Telnet. So you're going to want to go to that link, week3.ritsec.club, to get to the demo. The submission, this is a newfangled thing that just happened this morning. Scott stood up, so I think he's going to want to talk about it a little bit more. So I'm going to say my piece, and then I'll let him explain that a little bit. Basically, this week we're giving you a VM, which has a Cisco VIOS image running on it. Just like any version of iOS, you're not able to configure it unless you connect to it over a serial link. VMware has a serial port implementation. Bet you didn't know that. It's kind of annoying to use, and it's not very well documented. It's documented back from like a 2003 document that still works now. Really annoying. But basically, there are like several ways that they allow you to access this, and one of the ways is to automatically spawn like just plain text network traffic or a listener on that port on localhost that you can access to be able to configure it. The reason why I did this is because there are like 4 different ways that you could do that, which get increasingly more complicated. And this is the one that works like across all the versions of the operating system. I know I literally said you should not be using Telnet earlier on in this presentation, but because it's only on localhost and it's only for traffic like within your computer, it's pretty well mitigated. Yeah.
I have a question on flags.RITSEC. Is there a way to log into it without sending the password over clear text? Like, is there an HTTPS page for it?
Scott,
That's a rate limit question.
if anybody else has any questions about demos, I will be around during the Sec Lab or portion of this. But Scott Brink will actually answer that question and talk a little bit more.
But we'll fix that.